Okay, so in this video here, we have a triangle inscribed inside a circle, and we're being asked to find the radius of the circle. Now we're told that this triangle is going to be an isosceles triangle, triangle ABC, and that D is going to be the center of the circle. So at this point here, go ahead, pause the video, see if you can figure it out, and then come back here after you give it a shot. And with that being said, let's talk about how we're going to solve the problem, because this one is definitely challenging. It is not obvious, but you can actually do it just by using the Pythagorean theorem. Okay, so your first step here, you see that you have this right triangle inside. So for example, triangle ABE, if you're looking at this right triangle right here, we should probably go ahead and find the side length AE first and then go from there. Again, we're looking to get the radius here, but we have to start somewhere. So the first thing that I would do, again, I would get side AE. And again, I'm going to do that by using the Pythagorean theorem. So we know that this right here is going to be my hypotenuse, 3 root 5, and that the other side length is going to be 3. So again, I'm going to use Pythagorean theorem to get side AE. So I'm going to go ahead and do that. So I'm going to say AE squared plus 3 squared is equal to 3 root 5 and then squared, okay? And so when we do this, we get AE squared plus 9 equal to, well, this will give me 9, this will give me 5, so I'm going to do 9 times 5, I get 45, so equal to 45. And then from here, I have to minus 9. When I do that, I get 36. So AE squared is equal to 36. And then I have to take the square root on both sides, meaning AE is going to be equal to 6, okay? So now we have side AE. Now, how does that help us, or does it help us? Because again, we want to get the radius. And so from here, what do we do? Because again, it is not very obvious. But one thing I see that we should probably write down is the radius. So for example, going from A to D, that length there is going to be the radius, because again, we know that D is the center and I'm going to the edge of that circle there. So AD is the radius. Also, B to D will also be a radius. So what I can say here is AD is equal to BD, which is equal to our radius, okay? So what can I do from here now, right? So how do I get the radius? Now, if you look at this triangle right here, you have another right triangle, the smaller one right here, okay? And I have one of the side lengths already. That's going to be 3. And BD is the radius. That's what I'm trying to find. And I have this bigger side length right here, AE, but I need DE. So think about how you could write the side length of DE based on AE, right? The side length that you already have. Well, think about it. If I do AE minus AD, that's going to give me DE. So for example, if I do side length AE minus side length AD, so minus AD, that's going to give me DE. Okay, that will give me DE. And so how can I use that to my advantage? Well, I know what AE is. AE is going to be 6. So I can replace that with 6. So in other words, I can just call DE 6 minus AD equal to DE, okay? So I'm essentially just going to call side DE 6 minus AD and go from there. And you'll see why we're doing this. We're going to be able to essentially get it all in terms of the same variable, and then we'll be able to solve for the radius, all right? So let me go ahead and scroll down. So doing this problem, I know that I have to do 3 squared, right? This 3 right here. And then 6 minus AD squared, right? And then equal to BD squared. So I'm going to say here, 3 squared plus, again, DE, that's going to be 6 minus AD, and then squared, equal to this length right here, BD. That's my radius, right? BD is my radius. So I'm going to put BD squared. Now think about it. If you go back up to what I wrote up top, we know that AD is equal to BD, which is equal to our radius. So AD and BD are both the same, and they're both equal to my radius. So what I can do at this point here, I can replace both AD and BD with R, the radius, and then I can solve for R. I'll get my radius, okay? So I'm going to say here 3 squared plus 6 minus R squared equal to R squared, okay? From here, we're going to do FOIL. I have my binomial right here. So doing FOIL, we get 6 minus r times 6 minus r. So we have to do first, we get 36. Doing outside and inside, you get minus 6r, and then doing last, you get positive r squared. Combining like terms here and here, you get negative 12r. So 36 minus 12r, and then plus r squared. So this whole part right here, we just simplified it down. We got this expression right here, okay? So I'm going to go ahead and write that. So scrolling down, we have 3 squared, which we know is 9. And then this whole part here, plus 36 minus 12r plus r squared, right? And then equal to r squared. So look what's going to happen here. I have the same term on both the left-hand side and the right-hand side of the equal sign. Whenever that happens, they will essentially cancel out, right? So these are gone, okay? And now I'm left with 9 plus 36. That will give me 45. So I get 45 minus 12r equal to 0, okay? So I get 12r is equal to 45. And so from here, we just divide both sides by 12. And when we do that, we get 3.75. So my radius here is going to be 3.75. There is our radius, okay? Now we're not given any units here, so we're gonna leave it unitless, okay? So 3.75, you could put 3.75 units, that's fine. I'll just leave it as 3.75, all right? And so that is it. And again, that was not very obvious. We had to substitute in a way that was not very obvious, but hopefully that opened up your mind to how you can substitute in ways that, again, are not very obvious and can be obscure at times. So I hope that you learned something from the video. I hope that you gained something from it. If the video did in fact help you, if you could just go ahead and give it a thumbs up, that'd be greatly appreciated. Also, make sure you subscribe. That way you get more math videos in the future, and I'll see you in the next one.